Hey everyone, welcome to today's video. In this session, we'll dive into exploring Python classes. With classes, you can improve code organization, reusability, and maintainability. By encapsulating data and functions into a single unit, classes promote a more structured and modular approach to programming, making it easier to understand, debug, and modify code. Let's see how Python classes work through an example. So I have here in Markdown in Jupyter Notebooks already a situation, an example. So you are working with a group of environmental science students monitoring the temperature in Fahrenheit at different locations in San Antonio, Texas. They have deployed several sensors at various points in the city to collect temperature data. The data from these sensors is automatically logged and stored in a database. You plan on using Python and Jupyter Notebooks to retrieve the sensor data, analyze it for trends or anomalies, and potentially identify microclimates within the forest. You have started modeling the material using a class for sensor data, and you plan on revisiting your class to ensure it is well designed. So first, let's write the class. So I'll write here class temperature data. And this is generally syntax, a well-practiced programming method of capitalizing each word in the class. So temperature data. So the first method we want to create is the init method. So it's called the constructor method, which creates the object. It initializes the object's attributes when a new instance is created, a new instance of the class temperature data. So let's go ahead and write init self name readings. So self allows you to modify the attributes and behavior of the specific object. And we're going to take in two parameters of name and readings, just the name of the sensor, and a list of the temperatures, which are going to be the readings. And then inside this constructor, let's establish self.name equals name, self.readings equals readings. We also want to create a function for solving for average temperatures. So we can do def calculate average temp, self return sum self.readings divided by len self.readings. So this is just your typical function for calculating average, where you sum all the readings and you divide it by the number of readings. Another method that we can define is finding the highest temperature in this list. So we can do def find high temp and return max self.readings. So the max function allows you to find the highest reading in that list. And then similar to high, you can find the lowest. So it would simply be find low temp self return min self.readings. And let's see if we have no errors here. So I went ahead and ran it, no errors. So now let's write the main part of the program. But before we do that, we want to create a short function to find the difference between two numbers that will help us find the temperature range from the list of functions. So let's do calc range, calculate range, first, second number. And then to account for negatives, we do if first is greater than second, return first minus second, and then else, if it's the other way around, return second minus first. And let's see. And then after this, we can create a name for the sensor. So I can go ahead and come up with a name. Let's just call it the sensor in North San Antonio. So I'll call it here. And then we want to get an instance of that class. So here we assign the variable sensor is equal to temperature data sensor name, which we had assigned previously above. And then we'll give it a list of temperatures. So San Antonio is pretty hot, so 95, 99, 92, 93, 90. So after we created that, let's calculate the average temp using the function here, average temp. So average temp is equal to sensor dot calculate average temp. And because we created this class, we're able to go into that class and use their defined functions. And to show that, let's go ahead and print it using an f string average temperature for sensor. Okay. Now we can find the highest temperature. So sensor dot find high temp. We can do the lowest, sensor dot find low temp. And then just to show that, do another f string and say temperature extremes for sensor, which our sensor name, okay. And then we want to find the ranges, the range of the list of temperatures. So we do range equals calc range lowest highest. You can put either or just because of the function that we defined here. So calc range lowest highest, print temperature range for sensor Okay, so this is it. Let's see if we can run it. Lend, okay. I'm pretty sure it's len. So this is for the average right here. Name len self dot readings. Now calculate average temp. Okay, sorry, it's up here. I want to run that again. Then run this again, and here we get average temperature for sensor North San Antonio, 93.8 degrees Fahrenheit. The temperature extremes, 99 and 90, which that checks out. And the range, 99 minus 90 is 9, so everything looks good. But let's think about what we did in the beginning of this code block. We wrote a function called calcRange right here. Prior to creating our class and implementing class functions. If we anticipate that calculating the temperature range will be a common operation for analyzing sensor data, it's beneficial to have this functionality readily available within the temperature data class itself. So we want to put it right here. So this makes the code more convenient and adaptable for future use cases. So let's redesign this class. So let's, in a new cell, let's go ahead and copy all this and create this new class, fresh. So here we are, and we want to add that calcRange here. So we could do calcRange self return max self.readings minus min self.readings. So this is going to get us that range. So let's run this, and now our class is updated. So now we have a built-in function right here to our temperature data class. And now that we did that, let's copy and paste this to a new cell. And instead, right here, of range equals calcRange, I'm going to delete this because we don't need this anymore. So we can just do range is equal to sensor.calcRange, because this is the new function that we defined in our class. So let's go ahead and run this. And as you can see, same output as before, 93.8, 99, 90, and 9. So the updated code now allows you, as I stated before, to call the calcRange function without having to write the initial code here to do it. Even better, anyone using this class in the future will have access to the same method, simplifying development and making mistakes less likely. So to recap, Python classes improve code organization, reusability, and maintainability. By encapsulating data and functions into a single unit, classes promote a more structured and modular approach to programming, making it easier to understand, debug, and modify code. Thanks for watching, and I'll see you next time.